Hi, welcome back to Physics Teacher, the channel that prepares you for the high school math, chemistry, and physics contests from Waterloo University. This is a question from the Fermat contest from 2021, which is the grade 11 math contest. Give it a try, and I'll be right back with the solution. So in this question, we form an equilateral triangle with three unshaded dots. And then we take this equilateral triangle and place two of them next to each other and one on top. And in the middle, we fill with a shaded dot. And you can see we repeat that procedure over and over and over again. So here's the one triangle, and next to it as well, and on top. And then in the center, we fill in with shaded dots. And so the question is, if this is figure 1, and this is figure 2, and this is figure 3, at what figure n will we have at least 100,000 shaded dots? So we need to find some patterns here. Let's start by looking at the base. So in figure 1, we can see on the base of a triangle we have two dots. Now because we're simply taking two triangles and putting them next to each other, this triangle will have 4 dots, this triangle will have 8 dots. So if we're looking at the base, what we do each time is multiply by 2. So we consider the length of the base to be 2 to the power of n dots. Next, let's look at the total number of dots. So in figure 1, we have 2 for the base, and then 1 above it. In figure 2, we have 4 for the base, and then 3, 2, 1. And similar for figure 3, we have 8, 7, 6, 5. So what we're doing is to find the total number of dots. If you start from the top, we're doing 1 plus 2 plus 3, all the way up to the number that is in the base, plus b. Now a good way to calculate what the total is to look at the average. So the average, since we are adding consecutive integers, we can say the average of all of them is just the same as the average of the first one, which would be 1, plus the last one, which is b, divided by 2. Which is the same as finding all of these, adding all of them, so let's call that t for the total, divided by the total number that you have, b. So we can take this and rearrange it to get that the total number of dots t is equal to 1/2 b times b plus 1. Now since we already know that the base is 2 to the n dots, well, we can write the total then as 1/2 b, which is 2 to the n, times b plus 1, or 2 to the n plus 1. Next, I want to look at the number of unshaded dots we have in each figure. So in figure 1, we have 3. Now since we take this and we put 3 of those identical triangles in the next one, and then fill in the rest with shaded dots, well, the total number of unshaded we have in figure 2 is simply 3 times that in figure 1. And the same goes for figure 3. It's 3 times that of figure 2. So since each figure we're multiplying by 3, the total number of unshaded dots would be 3 to the power of n. Lastly, we want to find the total number of shaded dots. Well, since we only have 2 options, either shaded or unshaded, the total number of shaded dots would be the total of all dots, which is 1/2, 2 to the n, times 2 to the n plus 1. Subtract by how many are unshaded, which is 3 to the n. And now we have an equation we can use to calculate the total number of shaded dots. Now if you were to try some values of n, such as n equals 8, you would get the total number of shaded dots to be 26,335. Not quite 100,000 yet, but if you do n equals 9, into that equation, you would get 111,645. So that is the figure that'll give you at least 100,000 dots. So our answer is B.